Alright, so today we're going to continue on loops, and that will take us up until the first exam in the fifth week. That will cover everything from the beginning of the course all the way to and including loops. We'll start on additional material after that. In fact, we'll do a preview of it today, but that stuff will not necessarily be on the first exam. More details on how that fifth week is going to go with resubmission, redo, and the actual exam, closer to the exam date, probably next week. All right. But otherwise, we left it off last time. Remember that we are on Piazza, we are on YouTube, so if you have any questions, you can post to either one of those. But basically, we left off with looking at for loops and while loops. And they both had the exact same structure in that they had these four things, right? An initialization, a continuation, an increment, and of course you have to do something in the loop body, right? It's just that they differed in their behavior and their syntax on where that stuff actually went, right? In fact, let me clean this up. I don't know why it's probably a cut and paste kind of thing. There we go. There's our for loop, right? The initialization, the continuation, and the increment are all on the same line, all within the parentheses attached to the for keyword, right? After that, of course, the variable, if you declare it like this, that variable no longer exists. I is scoped only to the for loop itself. It exists at the beginning of the for loop. It exists towards the end of the for loop, but after the for loop is done, it's gone, right? In contrast, we have a while loop where the initialization is done right before the while. The continuation condition is done within the attached to the while. That's the only thing that gets attached to the while keyword. The increment is done inside the body, and there you have a little bit more flexibility. The increment is always executed at the end of a for loop, but with a while loop, you can put it wherever you want, right? You can put it at the beginning, you can put it at the end, you can put it in the middle somewhere, right? But otherwise, they basically accomplish the same thing. The question that we left at the end was, which one is better, right? So that's what I'm going to ask. This is our exercise that we're going to start out with, showing when generally you want to use a for loop versus when you want to use a while loop, because it's a non-trivial fact that you can actually rewrite either one. Yeah, go ahead.
A for loop is good for doing something a set number of times, while a while loop is good for doing something when something is true.
Good. A little bit more precise on that would be that a for loop could be is generally when you know up front exactly how many iterations you want to go, right? You can actually take any for loop and rewrite it as any while loop and vice versa, right? It's more natural when you want to use a for loop when you know that you want to go for, say, 5 iterations or 10 iterations, or more generally, if you want to write a for loop with a variable, right? 10. Int for int I equals 0, I is less than 10, I plus plus. This is kind of an idiomatic for loop. Now, we don't necessarily know what value is stored in n. That could be read in from the user, right? But we do know that there are going to be n iterations. There could be 5, it could be 10, it could be 15, 42, whatever. But we do know that it's n. And so it's more natural to think about this as for I running from 0 up to, but not including n, by 1, right? And that's the most natural use of a for loop. For a while loop, it's more natural when you don't know up front how many iterations you need to go. Instead, that's your condition for breaking out of the loop. When we get to a certain point, okay, now we're done, right? We've converged. If it's doing some math or something like that. We'll look at an example like that later on. The example that I'm going to show you, though, is when is it more natural to use a while loop than a for loop here? I'm going to give you a problem. Given a number, x, right, how many digits are in it, right? Now, number, I'll change that to an integer, right? Okay. So if I gave you, say, and now I'm just whiteboarding this, right? I'm just going to, putting out examples here. 1, 2, 3, 4 has 4 digits, right? 1, 2, 3, 4, 5, 6, 7 has 7 digits, right? Just as a corner case here, 0. How many digits does 0 have? Has 1 digit. What's another kind of corner case that I might want to think about? What about negative 1, 2, 3, 4, or 1, 2, 3. How many digits does it have? It has a sign, yes, but the sign isn't a digit. Right? Has 3 digits. Right? How can I compute that? Okay, so let's start out with an example. 1, 2, 3, 4. What if I were to divide that by 10? What does that end up being? 123.4. But if I do it integer-wise, truncating it gives me 123. Right? There's one iteration, right? And I counted 1 digit. What if I were to do that again? 3 divided by 10 is going to end up as 12.3, but then integer division will end up as 1, 2. Right? I've done this now twice, 3 times, 4 times. Right? So there's the idea, right? We've whiteboarded that idea. Now we actually need to get that idea into our actual code, right? We need to translate that that algorithm into actual C code. Right? Why does that work? When do I stop? ... When it's 0, I've counted how many times? I divided by 10 to get 123. 12. 1. And then 1 divided by 10 is going to be 0.1, but what happens with integer truncation? It becomes 0, giving you 4. How many digits were there in 1, 2, 3, 4? 4. There's my answer. Right? Now, why is it more natural to use a while loop for this problem instead of a for loop? Do I know how many iterations I'm going to execute up front before I start? No. If I knew that I was going to do 4 iterations, I'm done. There's my answer, 4. Right? So it's going to be more natural to think of this as a while loop. Right? So let's just go ahead and go with a prototype here. Right? Int x is, and I'll go ahead and hard code it to that 1, 2, 3, 4 value. Okay? We're going to improve this all until it's perfect all the way to the end here. That's why I made an entire different file here. All right, let's go ahead and go into a loop. Right? While x is greater than 0, right? When it hits 0, we want to stop, right? What I want to do is I want to divide by 10, right? And then increment a digit counter. Right? What did I do? I divided by 1, 2, 3, 4, divide by 10. That gives me 123, but I also need to keep track. I did that once. I did that twice. I did that thrice. I did that 4 times. Right? I need to know how many digits there are. So that suggests that I need another variable here. Int num digits. Where do I start it? I don't know. We'll come back to that. Divide by 10. How can I divide by 10? X is equal to x divided by 10. Right? The left-hand side, the left operand is a integer. The right is an integer. So we're exploiting the fact that we're going to get integer truncation here to erase that 0.4, erase that 0.3, 0.2, etc. Right? Now increment a digit counter. What was my digit counter? Num digits. Right, is equal to num digits plus 1. Okay? Great. Now let's go ahead and print it out. Printf percent x d has percent d digits in it. Right. All right? What am I going to be able to print out here? X and num digits? Yeah, let's find out if this works. GCC num digits. There we go. Uh-oh. Well, I wasn't done yet, was I? What's it complaining about? That question mark, question mark. Where should I start? How many digits to start out with? 0. Right? Why 0? Well, before I 1, 2, 3, 4, right? 4 digits here. I start my counter at 0, then I divide by 1, and I get 1 digit, 2 digit, 3 digit, 4 digit for a final count of 4. Right? What if I just left it like this? Undefined, potentially. Now, likely it's going to end up being 0, and so when I run this, it'll actually probably work, but for the wrong reasons, right? Because the default here is probably going to be 0. I need to make sure that that's explicit, though. Right? If I took that to another system where the default is not 0, the default is dead beef or garbage or whatever, right? Then garbage plus 1 is garbage still. All right, well, 4 digits, that's the correct answer, at least in this case. But, oh, wait, 0 has 4 digits in it. Is that correct? Nope. X was the original input value, right? And then I manipulated it, right? I said I divided by 10, and I used that to determine whether or not I should be done with this loop. So I still want to print it out. I want to print out 1, 2, 3, 4 has this many digits. What does that suggest? That I can't use X? I can use X, but I need to make sure that I have save the original value. How do I save the original value? Make another variable, right? You're not paying by the variable here, right? Go ahead and make another variable. Now, don't make a variable just to make a variable, y and z, right? And you end up not using either one of those. When I compile this with the w_all flag, it's going to warn me about that. Y, z, neither one of those variables is used. Why is it there? Get rid of them, right? A variable should only exist if it has a purpose, right? So I'll call this original value, right? And I'll call this one, I'll leave this one as x, right? Move this one up here, and then I'll set original value to equal to x so that we have the original value here. Original value. There. Okay? Compile that, and now every variable has a purpose, right? 1, 2, 3, 4 has 4 digits in it. Great. Are we done? I solved this problem? Well, I whiteboarded a bunch of test cases here, right? What are test cases? Test cases are a input and a known correct output, right? These are 4 test cases right here. 1, 2, 3, 4 is an input, and my output should be 4 because it has 4 digits. How do I know that that's correct? I just did it, right? I mean, that's simple enough that a human can look at it and say, well, yeah, there are 4 digits there, right? If you need some other means, like, for example, air distance, you can Google air distance calculator, right? The spherical law of cosines calculator, and use that secondary thing to check your work, to create test cases. You can pull out a calculator and do it. You can do it on a piece of paper, right? I'm doing it on a piece of paper electronically here. This has 7 digits, this has 1, this has 3. Yeah, go ahead.
Right now, 0 and then the numbers.
Save that until let's actually test it. Test the second one, right? And run that. 1, 2, 3, 4, 5, 6, 7 has 7 digits in it. If I didn't think about these corner cases, I'm done, right? It passes 100% of the tests. Does that mean that it's a correct code? Nope. You need to test a lot. And I could test a million different numbers here, and I still would not have a proof, a mathematical proof that this was correct. I would just have a very, very high probability and confidence that it was correct. All right? So let's go ahead and test 0. Predict what's going to happen, though. 0 has 0 digits in it. Okay. Why? Yeah, take a look at this while loop here. Is 0 strictly greater than 0? Nope. So when we divide this, this loop ends up not getting executed. We have the original num digits here. We have the original value of 0. Everything is unchanged. So what do we do? So a lot of you are in calc, I assume, where you've done calc before. Think about a function. Think about the following function: 1 divided by x. Right? What does that function look like? Tell me, or I'll graph it myself. All right. What happens? Yeah, well, yeah. It blows up at 0. What happens at 0? Is it defined? No, because it's division by 0 is undefined. Right? If you're in calc, though, can you take a derivative of this? Yeah, if you ignore 0, right? You can take a an integral of it everywhere except for 0, of course, because it blows off into infinity, right? So in other words, you can work with it in calculus as long as you ignore that one value, right? What do we call that? An edge case, right? A corner case, something that has to be dealt with by itself. And in this case, 0 is also our edge case. What if x is 0? I'm going to go ahead and treat that completely differently, right? if x is 0, then I'll say, oh, well, I'll just hard code those values, right? 0 has 1 digit in it. There we go. In fact, I would need to change the English because it's not even a plural anymore, right? So then I'll go ahead and exit with an error code of 0. 0 means no error occurred. The program went just perfectly fine. Right? All right. Let's run that and see if 0 has 1 digit in it. Great. Now again, if we didn't think about all these edge cases, we would have the misimpression that this is a perfect program. What happens when I go with negative 777? Or 123. All right. Predict. Yeah, it'll be 0 digits as well, right? Why? Because of the same problem with the while loop. Right? Solutions, suggestions.
Absolute value of x.
Okay. We could take the original value, right? I don't want to mess with the original value because I still want to print that. I don't want to lose negative 123. But with x, I'll say that x is equal to the absolute value of x. Is that correct code? Nope. So what do I need to use? The math library's absolute value function, which is abs. Now, you might have seen also fabs. Which one is correct in this case? Abs or fabs? Why? It's an integer, exactly. Fabs is for floating point numbers. Right? If you use fabs, or if you use abs for floating point numbers, then integer truncation. That 0.5 goes away. Right? So abs is good. 3 digits. Excellent. Except that I've made significant changes to this code in the last few minutes here. Right? I need to go back and test 1, 2, 3, 4 to make sure I didn't break anything. I need to go back and test 1, 2, 3, 4, 5, 6, 7 to make sure I didn't break that test case. That's called regression testing. A regression is like in sports. If somebody is performing very, very well, right? They have a batting average of 350 or something. Then it goes down because, of course, they need to regress back to the mean, right? You can't be, the best all the time unless you're Mike Trout or Ohtani or something, right? Nobody follows baseball. All right, fine. Anyway, you regress back to the mean. In other words, you go back, right? You make the progress that you had made is reversed. Right? Progress that I've made by fixing other bugs in this may have affected other test cases. So let's go back and test 1, 2, 3, 4. All right, good, still works. 1, 2, 3, 4, 5, 6, 7, 8, or 7, I guess, is what we said. Great, that still works. Right? Imagine every time that I made a change to the code, I did this over and over and over and over again. Right? This is ad hoc testing. Right? I would need to test this, make one little tiny code change, and you need to go back and repeat all of your work. Right? Does it sound like a good idea to repeat manual labor like this? No. That's the whole reason we write programs to begin with, to automate things. We need a program to automate our tests, which is exactly what you did in your lab on Tuesday. Right? We gave you an informal unit testing framework for the leap years. Right? We gave you 3 unit tests. And whether or not they passed or failed or whatever, we told you to make 3 more, right? And then all you had to do was compile the program and run it. Pass, 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 pass. Great. Oh, that one failed. I go back and make a change. Recompile it. Did I have to retest all those things? No, I just had to run the tester one more time. That's how the grader works. The grader has input and expected output. Then we run that through your program and look at your output and the expected output. Are those the same? This is exactly how testing works. Let's go ahead and get some practice doing that. Right? Now, the way that we did it in your lab was we gave you a preview of what functions are going to look like, which is the next topic. Right? But what I want to do is I want to take all of this logic, and I don't want to put it into main anymore. I want to put this into a unit of code called a function. Right? To do that, I'm going to go ahead and come up here. We'll talk about the specifics later. Right? but I will have a function called num digits, right? That's what it's called, right? The number of digits. It takes an input, x, right? And it produces an output, which is also an integer. Let me go ahead and document that. This function takes x as an input, and that should be familiar to you, by the way, right? What does math look like? Yeah, functions in math, what do they look like? F of x. What's the function's name there? F. F for function. We don't like that. If I called this f, right, what the hell is it a function for, right? No, I'm going to call it num digits because that's a descriptive name. Just like you don't have variables called x, y, and z unless there's no better choice, right? If you want to, you can call this input instead, right? X, okay? This function takes x as input and returns the number of digits in x, okay? I'm going to take all of this logic and move it up to this function here, okay? But now I want to generalize this. First of all, I don't want to hard code x to 1, 2, 3, 4, 5, 6, 7. It's given as part of the input here, just like a mathematical function, f of x. X is the input. F of x, when you evaluate f of x, right, then say that it's x squared. What's the actual value? When I put in a hard-coded value here, say 4, then what's the output? What's 4 squared? 16, right? 16 is the output. 16 is y, right? And that's what I'm doing over here. There's y, the number of digits in it. Okay? All right, I've got the original value. I've got x taking the absolute value here. And then num digits is 0. If it's 0, I don't want to print anything anymore because I want to return the number of digits in x. To do that, I simply return num digits. What value does it have at that point? 0. If you gave me 0 as input, I give you 0 as output. Otherwise, while x is greater than 0, I'll divide by 10, I'll increment the digit counter, and then at the end, instead of printing it out, I will return num digits. Okay? And again, this is a preview of what we're going to be looking at after we're done with loops. I just wanted you to get more exposure to more formal unit testing here, okay, earlier, because we have time, right? Before we go on, is there any, first of all, here's a good question, especially after we were done grading hack 2. Is this a good comment? No, why? It's just a rephrasing of line 20, right? Why is that not a good comment? Because it's cruft, right? Code is self-documenting. Everybody here knows that x equals x divided by 10 is meaning that you are dividing to x by 10. Don't repeat yourself. In fact, that's another principle, DRY principle. Not DIY principle, DRY equals don't repeat yourself. Right? So don't repeat yourself. That's cruft. Get rid of it. Right? This is good documentation because it says what the function is doing. Author documentation is good because it says who wrote this. But code is self-documenting, self-evident. This is also a bad comment. I'm leaving that out. I just did that initially as an outline, and then I filled it in with code. Go back and remove those things. Right? Is there a way that I can improve this line? X is equal to x divided by 10. Yeah, remember? We have all of these shorthands, right? We've got I++, which will add 1 to I minus minus, which subtracts 1. And then we've got these compound assignment operators. If you want to go I is equal to I divided by 2, or divided by 10 in this case, you can rewrite it as divides equals 10. Divides equals 10. Right? What about this? Plus plus. Shorter code is generally easier to read code, right? Generally. You can get too terse, right? You have to find that Goldilocks zone. Why do we call it the Goldilocks zone? It's just right. It's not too hot. It's not too cold. It's just right. Right? Not too verbose. Not too short. Just right. whatever it is. Right? All right, now I can go ahead and get rid of all of this code. Right? And I can simply call that function. On x being 1, 2, 3, 4, 5, 6, 7, int num digits is equal to num digits. Actually, this is kind of bad that I chose to be num digits. Number of digits. There we go. I want to draw your attention to the fact that this is a variable and this is a function. Just like square root is a function and you can give it x, well, now num digits is a function that I just defined. And then I've got x and num digits, number of digits there. Let's go ahead and compile this. Oops. Original value is never used, so I'm going to go ahead and get rid of it. There we go. It was an unused variable. It was cruft. Right. There we go. Let's run this again, and it should print out what? That 1, 2, 3, 4, 5, 6, 7 has 7 digits in it. Again, if I were to not automate this, I would have to go back, change that variable, recompile, rerun it, and see that it works. Or I could write code to automate all that for me. Right? How do we go about doing that? Well, I could do a loop. I'll just go ahead and hard code these for now, right? Where I'm creating an input, 1, 2, 3, 4, right? I'm getting the output here, and here's the, and I know what the expected output should be, right? Expected result. What should it be? 4, right? And I'm going to rename this to actual result. Actual result, right? And I'm not going to print it anymore because I don't care what the actual result is. I just care that the actual result matches the expected result. If the expected result is equal to the actual result, right, then this test case passes. Right? Otherwise, what's the opposite? Test case fails. Right? All right. So we can print that. Printf. Testing %d and dot dot dot. Actually, I'll put this up here. Right. Testing %d dot dot dot, and then x is our input here. So I'm going to be testing x, and if it passes, I will print out passed. There we go. End the line. Then I don't need that comment anymore, do I? You're printing passed. Obviously, it's passing, right? Otherwise, it failed. And we like those two words. Why? Because they both have 6 letters in it. And they align up perfectly. Right? Or you can go with pass, fail. Right? So let's go ahead and compile this and see what it looks like now. Testing 1, 2, 3, 4 passed. Excellent. Okay. Now that I've got the framework here, I can go ahead and copy pasta, copy pasta, copy pasta. But make sure to go back and change it. What was our other test case? 5, 6, 7. The expected result there was what? 7. Right? And if it matches, then it passed. Right? Otherwise, it failed. My other test case was 0, and my expected result was 1. Right? That either passes or fails. My other test case was what? Negative 1, 2, 3. Right? And that should be 3 digits. Now this won't compile because I did that bad thing of copy pasta, copy pasta, copy pasta. Why won't it compile? Do you immediately see what the problem is? Yeah. X, expected result, actual result. I declare it 3 times. Once, twice, thrice, twice, if that's a word. Right? Whatever 4 times is. Right? So I can't do that. I have to go back, and I'll declare all my variables up here. Int x. Expected result, or expected result, can't type, and actual result. There we go. And I will change all of these to just reset those variables. Reset those variables, reset those variables, reset those variables. Does anybody know block selection mode in VS Code? That's not it. Shift, command arrow probably. Shift command arrow. No. Whoa. Nope. Shift Shift Option arrow. Oh no! Whoa, that's weird. Shift Control arrow. Nope. Option Command arrow. There we go. Ooh, wait. Nope, that's. Oh, hold it down maybe. Shift Option and then highlight. There we go. Cool. What did I just do? Instead of, yeah, multiple lines, but if normally if I do multiple lines, it looks like this. What do I want to do? I want to get rid of all those ints. So Shift Option, and then you can highlight it as a column. Right? That's called block selection mode. Some IDEs you can go into the mode and just stay in the mode. This one, I don't know how you get into the mode, but on a Mac, that was Shift Option, and then you highlight whatever you want. Right? You can go ahead and go Shift Option, and then select that part right there.
And on Windows, that would be Shift Alt.
Shift Alt on Windows. Thank you.
You can also select the int and then hit Control D enough times to select all the instances with that.
Oh, okay. All right. Cool. All right, let's go ahead and run this now. Okay. What's wrong? Pass, failed, pass. Good enough? 75%. That's a C. Solid C. C's get degrees, right? Especially in engineering. Right? So, is that good or not?
No, you need to pass all of the tests.
Yeah, I need to pass all the test cases. Think about it like this, right? If we were to go to civil engineering is on this campus too. If we were to go over to civil engineering and talk to a bridge builder, right, and ask them, well, is it important that among the millions of bolts that we put into this bridge, what if one of them was missed? What if one worker just went to lunch early? Is that going to matter? And the bridge builder will probably say, 1 bolt out of a million? No. We've built in a tolerance that you could probably lose like 10% of the bolts and we'd be fine, right? Can you afford that in software? Can you afford to lose 1 digit in software? If you do, it all blows up, right? It's not like a natural engineering, like or a physics-based engineering, like bridge building or civil engineering, stuff like that, right? The tolerances are far, far fewer. That's why we do not like non-passing test cases. So what's wrong? Zero wasn't accounted. Well, we've got 0 here. The expected result is 1. And it says passed. Okay. Let's take a look at our the first thing I would suspect is maybe the test case is wrong, right? That's a false negative, right? It's telling us that it's a negative test case here, that it failed, but maybe it's a false negative. Maybe I screwed up and said the expected result is actually -1, right? Or -1 digits in 0. Nope. That looks right. Okay, fine. Let's come back up to here. Okay. Go ahead.
Where's the num digits?
Right there. Right there. If it's x is 0, it does in fact work.
Where your diff from 0.
I return 0. Good. What should I be returning? 1. There we go. Now, do I have to go back and do all my regression testing? Did I have to type? Oh, 1, 2, 3, 4 passes. Type. 1, 2, 3, 4, 5, 6, 7 passes. 1, 2, 3. All right. Do I have to do all that crap?
Nope.
No. What do I have to do? Compile and run it. Pass. Right. Awesome. That is the true power of unit testing, right? And having this is actually an informal test framework, right? Just writing these things out. Later on, we'll actually use a formal test, a unit testing framework called CMACA, where all this stuff is taken care of for you, right? Because I also want a summary report, right? I don't want to look in, okay, pass. If 100% passes, I just want to know that, right? So let's go ahead and add that framework as well, where I've got, say, int num passed, 0, int num failed equals 0. And then what I'm going to do is every time I pass, I'm going to increment that counter, ++. Right? If you pass, then you increment that counter, increment that counter, increment that counter. Every time you fail, you increment the other counter, num failed, ++. There we go. Lots of boilerplate, cut and paste, repeat, right? Not great. That's why we use a formal unit testing framework that takes care of all that stuff for us. Right? But I'll have a summary report here, right? Printf percent passed is going to be percent f, and we'll just go out to 2 decimal places here, right? And the line. And then what would be the percentage of things passed? Well, the num passed divided by the total number of tests. What's the total number of tests? Num passed plus num failed. Right? Still a bug here. Hopefully you can see it immediately. Actually, 2 bugs. Okay, you're going to tell me about it. Don't tell me about it. That's just a warning. There we go. Pass. But percent passed is 0%. How do I get a percent sign just to make it look nice? 2%. There we go. So, is that true that I failed them all? I passed 0% of them. If you want to, you can print them all out. Printf, number of tests passed, percent %b and the line, num passed. Number of tests failed. Oh, failed. Num failed. There we go. Yeah, what am I doing? Integer divided by integer plus an integer. Okay, what's the solution? Yep, make it typecast it so that at least one of them is a double. There's still an issue here because 1%. Yeah, it's on the scale of 0 to 1, right? So what would you want to do here? Times 100. In fact, you can go do that and get rid of your typecast if you want to. Is that correct? Yep. Mathematically, it's correct. There, 100% pass. Right. Cool. The only other thing that I would suggest here is to align everything up, right? Let's go ahead and go with 10D, 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 and 10D. Right? Why? Because I just like it when things line up and they're nice and neat, right? Testing that number, pass. Number of test cases passed, number of test cases failed, 100%. Right? That's what you should strive for as we start introducing more formal testing in the actual grader. Right? What we'll do is later on when you do more sophisticated programs like this, where you're actually making your own functions and your own libraries of stuff, all we do is we've written stuff like this that randomly generates a million, say, arrays, a million different possibilities, computes the actual output, compares it to your output, and then says passed or failed. Right? You're not going to be able to look at a million cases. Right? You're going to have to look at your own 5, 6 test cases, right, to make sure that it's working. So there is an informal unit testing framework built in about 30 minutes here. Right? Now all it takes to add one more test case is what? Copy, paste. Give me another test case. I think that the over-under was 61. There we go. Oh, and then got to make sure that it's correct test case. Yep, there, 5. Right? That only took me what? 2 seconds to make yet another test case. Right? Once you've got the framework there, making more test cases is trivial. Right? All you have to do, the biggest amount of work there is actually figure out what the actual output should be. Right? And by the way, this is not the way to go about doing it. Let me go ahead and make one more test case. I wonder what it should be for, I don't know, 77777. Right? I don't know how many 7s I typed there. So let's go ahead and output the actual result. Printf actual result was ... %d and the line. Actual result. There we go. Let's compile it, run it. Okay, the actual result was 5. Okay. So I need to go ahead and make that 5. Is that a test case? No. I used potentially buggy code to determine what the answer should be rather than something external to the code. Right? Don't do that. But it is 5. This is a simple enough exercise here that all of our test cases were pretty straightforward. Right? It also demonstrates, again, the for loop versus a while loop. I'll make sure that all that's in the notes later on. All right? You can also nest for loops. Right? What does nesting mean? Well, if you've got a nest, you can put something in the nest, right? Then you can have a nest within the nest, and you can have a nest in that nest, and nest, 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 right? You can have as many as you want. You can play, in this case, you can place a loop, or a loop, within a loop, right? A nested loop. We refer to them as the inner loop and the outer loop. Let's go ahead and go over here to demo and look and see what that looks like. For int I equals 0, I is less than 10, I plus plus. Oops. There's my outer for loop. And I'll just go ahead and print I. I is equal to %d and the line I. Right. There's one loop. What I'm going to do is I'm going to put another loop inside that loop. For int I equals 0, I is less than 10, I plus plus. Can I do that? How many I's do you see now? Oh, I see at least two. There's an I, and there's an I. Right? Let's see what the compiler has to say about this. It's fine with it. Okay, which I is I? So the compiler's fine about this, because if you refer to I in the inner for loop, it will only ever refer to that loop. That I loop in the loop. Don't do this. You can do this, but don't do it. Why? It's too confusing. All right, we already used I in the outer for loop. This is the inner for loop. What should I name my variable here? J. All right, and J. All right, why J? A, B, C, D, I, J, K. All right. Yeah. So you'll get yourself into a habit here of, oh, okay, well, I need the same for loop. I need the same for loop. I need the same for loop. Okay, I have to change all the I's to J's. I have to change all the J's to K's. Right? Copy pasta gets you down the bad road again, where you miss one. Right? So now I've got I, J, J, J. Right? And I will also print out J equals %d and the line I and J. Now tell me what this is. Predict what this is going to print. Oh, okay. Predict how many things it's going to print. 100. Why? The outer for loop runs from 0 up to 10. For each iteration of the outer for loop, the inner for loop runs 0 to 10. Right? So yeah, exactly. N squared. In this case, n is 10. 10 times 10 is, math majors, 100. Right? What exactly is it going to print, though? Yep, let's go ahead and jump all the way back up here. 0, 0. But then does the inner loop change I? Nope. The inner loop runs from 0 up to 9. 0 up to 9. For each I running from 0 up to 9. 2, 3, 4, 5, 6, 7, 9. Right? 100 times total. You could do this for int k is equal to 0. K is less than 10. K plus plus. There we go. And print out k as well. And now how much is this going to print out? 1,000. Right? I'm going up by an order of magnitude each time. Should I make another for loop? I could. At that point, it becomes kind of ridiculous. Right? In fact, anything more than 2 loops, really rethink it unless it's absolutely necessary. You probably could do this a different way. Right? What if instead I had parameterized all these? N, N, N. And I set int n equal to 10. That's the same as before. It's going to print 1,000 things. How many things is it going to print now? 1,000 times 1,000 times, or sorry, 100 times 100 times 100. 3 loops here. So, what is that? 100 times 100 times 100. What do we call that? We don't know. 100 cubed is what? Million, isn't it? Yeah, it's a million. Order of magnitude more is cubically a cubic growth, basically. 1,000 times 1,000 times 1,000 is what? We call them billions, right? We call them trillions. We call them quadrillions. Can you do it? Yeah. How long is it going to take?
Quite a while.
Quite a while. So the, programs are usually I/O bound. What I'm doing is output. So I'm bounding. This is a really expensive. This is like 99% of the CPU cycles are, or the wait time, the actual time is being wasted here in the print statement. Right? I'm going to go ahead and create a count. I'm not even going to be able to do that. I'll just say do nothing, but do it really fast. Printf, done. I don't know, it might actually end up optimizing this away. I don't know. All right, let's do some benchmarking. Benchmarking is testing. If I started out at 10, all right, then this is almost going to be instantaneous, done. I can time it, and it'll tell me that it took a real time, in real time it took me 0.002 seconds. Okay, let's go up an order of magnitude here. Right. This should take me 1,000 times longer. It's not that exact, 3 times as much. Right, for very small values here, it's not going to be noticeably different at all. 1,000, this should be roughly 1,000 times slower, which would be about 6 seconds. That's about 2 seconds, so 3,000 times slower. If we looked at that trend as it tends towards infinity, what's this is going to be? That was, remember, 3,000 times slower.
2,000 seconds?
Yeah, 2,000 seconds, what's that? 2,000 seconds, 2 minutes. That's 33 minutes. Right? Nope, I don't want to do that. I just killed it prematurely. We called those quadrillions. We call them quintillions. I don't know. So that's, say, 2,000 times slower. What's 2,000 times slower than 2,000 seconds? 60,600 minutes. Okay, we're not even in minutes anymore. Years. Okay, it's not quite a year. Days? 46 days? Yeah, there we go. So, want to wait around? Now, this is just, I'm not actually doing anything here, right? But imagine if I wrote a loop like this and I was actually processing real data. Is this feasible? No, right? It is not acceptable to wait 46 days for your computation. Maybe you can do an overnight thing, right? Okay, we'll tolerate 8 hours here, but 46 days, that ain't happening. Right? I'll let that run while we talk about those notes, right? All right. Again, don't nest loops unless you really have to. It's called a code smell. Right? A code smell is something that's not necessarily bad, but it probably stinks. And if it stinks, it's probably rotten. And if it's rotten, you want to take care of it, right? Some things smell bad, and that's what they're supposed to smell like, right? What's that fruit? The durian fruit, or what is it called? Durian fruit, right? Or lutefisk, or something like that, right? It smells terrible, and it's supposed to smell terrible because it tastes great, supposedly. I've never actually had durian fruit. Anybody did? Anybody has? No? Okay. I don't even know if you can get it here. Oh, you can? All right, cool.
You can get a lot of things there.
That sounds really nefarious. All right, so consider the following code here. Pitfalls. just like with conditionals, we have some issues here. What's going on there? Yeah, what's the semicolon there doing? That's similar to a pitfall that we had with conditionals. If we had an if statement and then a semicolon right after it, if this condition, do what? Do nothing. While I is strictly less than 10, do what? Do nothing. And that results in a... Oh, here, I'm going to kill this. All right, there we go. GCC, and run this. Okay. I won't time this. All right, while I is less than 10, do nothing. Do nothing, do nothing, do nothing, do nothing, do nothing. All right, all it's doing is...
I will always be 0.
Yep, it'll always be 0 because I never get to that point down there. While I is less than or equal to 10, do nothing, do nothing, do nothing, do nothing. Right? So don't do that. Undo, undo, undo. And GCC demo. The same tool that we were using before, the WAL flag, the linter, will be able to detect something like this. The while clause does not guard. Are you sure you did something right there? The semicolon there probably is not what you want. Right? Here's another pitfall. Again, it'll result in an infinite loop. How do we kill infinite loops again? Control C. There we go. Here's another piece of code. What's wrong with it? It never increments I, results in a infinite loop, and you can kill it with a Control C. Right. Here's another piece of code. One of these things is not like the other. I don't have my my opening and closing curly brackets here, right? Let's go ahead and put this here. Everything's indented, so it looks right, but I don't have my opening curly bracket, my closing curly bracket. I wonder what happens here. There we go. Ignore. Again, using a linter will give you a huge red flag warning that there's something wrong here. But not using it, well, everything's fine. Right. Yep. 0, 0, 0, 0, 0, 0, 0, 0, y. While I is less than 10, do the next thing. Now, the next thing, if you had a proper loop body here, with opening and closing curly brackets, would be everything inside those brackets. Without those brackets, what's the next thing? Just the next line, print. It never actually gets to the plus plus. Right. Kill it with Control C. Make sure that you've got proper parentheses, or curly brackets, excuse me. And always, always, always go with the WAL flag. It'll find things like this, right? It does not guard. The latter is misleadingly indented as if it were part of the while loop, is what that means. Right? Okay. Pitfalls, pitfalls, pitfalls. Right. This is simple enough, but I've got a bunch of exercises here. These are standard exercises they usually do. Let's just go with the first one. Write a solution to FizzBuzz. Anybody ever heard of FizzBuzz before? Okay, 1, 2. All right, let's pull it up. Credit to what's his name? FizzBuzz. I can't programmers program. Right. What is his name? He's the founder of something that you will probably really enjoy, Stack Overflow. Right? Anytime you have a programming question, you Google it. Usually it's Stack Overflow that comes up, and that's the guy that that founded Stack Overflow. Jeff Atwood, there's his name. Right? And a long time ago, well, not a long time ago, 2007. So this program was it's an interview question. Where's the statement? Here's one. Write a program that prints numbers 1 to 100, but for multiples of 3, print fizz instead of the number, and for multiples of 5, print buzz. For numbers which are multiples of both 3 and 5, print fizz buzz. And this is basically a Weeder interview question, right? You go in for an interview, and they say, okay, great. Before we talk about the salary and anything else, here you go. Write us a FizzBuzz program. You know Python? All right, prove it. Write FizzBuzz, right? Something that anybody that's taken a computer science 1 or a programming 1 course could do after the first, literally, now we're in the 3rd week, right? And the article that he writes about it is, well, we were able to get rid of like 99% of all applicants with this simple question because they couldn't do it, right? Now, were they lying about their credentials? Were they just nervous and they couldn't do a simple programming task like this? Who knows, right? That's what the entire article is about. That surprisingly, it was a good predictor, or it was a good filter for that first one. Unfortunately, nowadays the filter is all automated through a CV process or your resume process. But if you ever do go into a technical interview, eventually you will, right? You might be asked to write something stupid like FizzBuzz. You will immediately, after 4 years of a degree program, you will be insulted, but knowing why they do it, you won't be insulted, right? They're trying to get rid of all the idiots that don't know how to do it, right? Or that claim that they have these skills and they don't, right? So again, what is it? We need to print out numbers 1 to 100. If it's a multiple of 3, so what are multiples of 3? 3, 6, the modulus is what we're going to use. 3, 6, 9, 12. Those are all multiples of 3. We're going to print out fizz instead. Yeah.
Would it also be anything that you could divide by 3 without getting a remainder?
That's exactly what we're like 3 divided by 3, what's the remainder? 0. 6 divided by 3, what's the remainder? 0. But 7 divided by 3, what's the remainder? 1. That's not fizz, right? 5, we print out buzz. So 5, 10, 20, 30, 40, we print out buzz. Except that if it's divisible by both 3 and 5, we print out fizz buzz. Right? So what's a multiple of 5 and 3? 15, 30, 45, etc. Right? So there's our task. Fizz buzz. Right? Print out the. Let's start by printing out the numbers 1 to 100. For loop or while loop? 4? Why 4? Why was that more natural? Why did you immediately jump to a for loop? We know exactly how many we want to go with. Int I starting at 0, 1. It said 1 to 100. I is less than 100. Less than or equal to 100 because it said 1 to 100. Right? And I plus equals 2. We go up by 2. 1, 3, 5. No, we just go up by 1s. Nice little idiomatic for loop here. Right? Now, if it's just the number, I print it out. Printf, %d, and the line, I. Right? There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way up to 100. Right? We're halfway there already. How do I tell if something is divisible by 3? Modulus. If I mod 3, I divided by 3, the remainder is 0, then it's divisible by 3. What do I print out instead? Is. Not the number. Else. Let's make sure that that works. Right. They also timed people, right? And like there are horror stories in here. And if you go down to the comments too of people saying, well, they eventually got it, but it took them an hour. So, yeah, we ended up not hiring them. All right. So, fizz, buzz. I'm not going to take an hour here. Let's make sure that this works, though. There are 3 fizz. 6 is fizz. 9 is fizz. 12 is fizz. Okay. Now what? Okay, what if we did it like this? If I mod 5, remember it's divisible by 5, has a remainder of 0, I'll print out buzz instead. There we go.
If you're on the same line, then another print new line.
I'm not sure what you mean.
It's supposedly fizz buzz, one word.
if it's 3 and 5, right? I just want to take care of 3 and then 5. Right? Let's try this. Do you immediately see what I was what's wrong here, though? All right, it never prints fizz buzz, but we haven't gotten there yet. Let's go over to 15. Right? Fizz, and then buzz. Right? That's what you meant on 2 lines. Right? What's the issue? If should these be 2 conditions, or should they be mutually exclusive? You either print fizz, or you print buzz, or you print fizz buzz, or you print the number. I want else if. Okay. And now I won't get fizz buzz. That's the last task that we're going to do here, right? But I will get, for say 15 here, I will get fizz. Why? The first one that is true is the one that gets executed. Right? Okay, I have to take care of both of those. Right? So let me go ahead and put down at the end. Don't correct me, I'm trying to make mistakes. I mod 3 is equal to 0, and I mod 5 is equal to 0. Else this. Oops. Print fizz buzz. There we go. Make sure that the syntax is all correct. Great. So now our test case should, oh, okay. Yeah, what's wrong? Ampersand, ampersand. Right? Don't be hacky. And I'm not even going to show it to you. Yeah, no, I don't want to lead you astray. Right? There we go. All right. 15. Does it work? Nope. It should be fizz buzz. Order matters. When things are mutually exclusive, the first one that's true is the one that gets executed. I mod 3, 15, it has a remainder, 15 divided by 3 has a remainder of 0. We have fizz here. We never get down to fizz buzz. The most specific cases come first, then the most general. That's why it's an else statement. If none of these things are true, then this is the catch-all down here, right? The else thing. So most specific to most general. So where should this condition be? At the top. If that's true, then do that, else if. And I've gotten myself into such a mess here. How could I fix it? A style, remember? That's probably the biggest thing that we've seen in the hack 2 is bad styling, bad indentation. It looks like maybe it's a copy-paste issue or something like that, or you downloaded it and then tried to open it up in a different editor that screwed up all of your indentation, right? So be careful there. Now, does this work? Looks like it to me. 1, 2, 3. 3 is fizz. 4, 5 is buzz. 6 is fizz. 9. Now let's jump down to 15 here. Fizz buzz. What's that? Should be the next fizz buzz? 30. What should be the next fizz buzz? 45, etc., etc. Right? Excellent. Suggestions on improvements here.
You could skip the first case and print fizz and buzz on the same line, do a new line.
Okay, you could do some convoluted logic. Yeah, I would not suggest that, because clearer code is better code. Right? Tricks are for kids. Don't write a trick code. Right? But what about this line right here? If something's divisible by 3 and 5, what's it divisible by? 15. Shorter code is better code. Right? And that's all I want to improve there. That's good enough. Ship it. Right? Again, in engineering, what's better than good? Good enough, exactly. Right? This is good enough. Right? That bridge is good enough, even though we forgot 20% of the bolts. All right, any questions? No? All right, then I'll see you over in your lab today.